Hello and welcome to another edition of WoodChat. I'm Sam.
And I'm Georgia. A warm welcome back to all our wood chatters. In today's episode, we're excited to be learning about yet another fascinating industry innovation.
We'll be discussing a Forest and Wood Products Australia funded research project focusing on prefabricated timber systems in construction and the use of deep breath, radio frequency identification technology, or RFID, which I think we'll probably refer to it as from this point forward.
Although its name might make it sound like something complicated, the idea behind this technology is actually pretty straightforward. Basically, small computerised tags can be attached to construction components, manufactured off-site, for instance CLT panels, wall frames and flooring systems.
These tags can be used to store real-time data and information about each component, including its properties, records of repair, maintenance and inspection history, treatments it might have undergone, as well as where it currently sits in the construction process and where it's going next.
Exactly. And then by using these electronic readers, contractors can unlock all this information stored in these tags, allowing for easy identification and tracking of construction elements.
So that's a very top-line summary of the technology and what it can do. But to delve a bit more deeply, we spoke to Perry Forsythe, Professor of Construction Management at the University of Technology in Sydney, who is leading the research.
I've always been interested in innovation and new techniques of construction, and I've been involved in prefabrication and trying to help the timber industry transition to higher levels of prefabrication.
And so what was it then that attracted you to this particular project that we're talking about today?
Well, as I said, I'm interested in trying to improve both prefabrication and timber. I think they're a bit linked, or I think the future of timber, especially moving to taller buildings, is around prefabrication and improving productivity on site and moving away a bit from traditional labour-based methods of construction. We had done a lot of work where we've done time-lapse photography of a variety of multi-storey timber projects, and we aim to measure the productivity on those projects. So we can measure crane cycle times in minutes, even down to seconds. We can look at how many workers are on the deck, so we can work out how many square metres are installed per hour using crane time and labour time. What we found out was that even though the crane cycle is very efficient and fast, there are often gaps in time, waiting time, a little bit of confusion sometimes, wrong deliveries turned up. Is this the correct panel to go in? And so we said, well, gosh, there's this degree of wasted time and not the high efficiency of workflow that you could have. And we realised that it was essentially a logistics problem, which is not that common in construction, but as you move to these prefabricated methods with many very large panels coming to site and trying to have a cyclic process using cranes, that logistics becomes a bigger deal. And trucks need to turn up with the right panel on the top of the stack, not on the bottom. If you're in a busy urban building site, there's no room to spread out 20 square metre panels all over the ground to find the one you want. Also, panels quite often look the same, but they have a different chase in it for services, for wiring or plumbing. They might be very different in size or different edge detailing. And so sometimes the wrong panel gets put in place. And all these things slow things down to a surprisingly large proportion. So we thought RFID technology, or being able to track an object and identify it, was a good way to go in addressing these issues.
Taking a step back, the RFID technology that's been mentioned, are you able to tell us a little bit about what exactly that means?
It's a little bit like barcode technology, but improved. And everyone knows barcode technology. You see it at the checkout at the supermarket or at buying a piece of hardware at Bunnings or something like that. What it does is it tracks an object. In our case, we're interested in prefabricated panels or roof trusses or large objects. And that's more important than it might first sound. You've got real-time information about where that panel is in a process. because it provides a time and date stamping. You know when it arrived, you know when it's been served up to a machine to be routed or drilled or cut. When it's finished, it goes in inventory, and we know what happens when it goes to site. We know exact times when that happens. And it allows you to monitor things and automate processes more. So that's what you get out of it. How you do it is you have a tag that can vary in size. They can be quite small. There's many different form factors. We're mainly talking about a synthetic paper tag that might be about 6 inches by 8 inches that can be stuck onto a large panel. It's that size because it's easy to read, physically read. It's got a mini computer chip in it that can read and write information. So in that respect, it's a little bit like a really tinsy-wincy USB key. And it holds information about the object that you're sticking it on. Its thickness, its size, its maybe certifications around fireproofness or noise resistance, things like that. In that tag, there's also an antenna. And this is all in more or less a flat piece of paper. So it's a very minimalist approach. And then you have a reader, a handheld reader, or even something like a smartphone is a possibility. And it reads information off the tag. You just simply point at it and shoot. The tag sends the information to the reader, and the user can either read it directly off a screen, or they can find out more information off a cloud database. It can read panels from distance. It can read through layers of the construction. So instead of it being like your shopping situation where you have to run the package right past a reader, you don't have to do that here. You can just point and it'll pick up maybe a whole truckload of panels and see if the ones that are expected to be in there are actually in there.
So in terms of this research project then, could you give us an overview as to how that's looked so far?
Well, the project is essentially about seeing if there's a value proposition for RFID technology in prefabricated timber construction. And so our early steps were to go out and do a lot of interviews with industry people, with those involved in the supply chain, with what you might call vertically linked people in the chain. So you start off with a timber supplier, then there's fabricators that make bits of timber into panels. They might often use some design engineering software to help design those panels and what size the timbers need to be. Then we have building contractors who are going to use it, and they're confronted with using less labour on site and moving to a prefabrication model. Then we have the owner of the building, and eventually the owner might own that building for many years, and they've got a facilities management need to know how to manage it and do maintenance on in this case, the timber construction.
Oh, so that information stored then is there forever, so it can be looked back on for the lifespan of the building?
Absolutely. Well, as I said, there's a read and write ability. If you really wanted to delete something, you can, but the idea is exactly as you say. You will show this lineage of where it is in a building process, and then once it becomes a finished product, so to speak, people can look back and find out exactly what's in there, and it can provide information about repair, maintenance, durability during its whole life. So it provides a history that's active insofar as you can update it. You can even say it was inspected for termites on this date, 2 years into its operation, and the next one's due in 2 years, so that it can prompt the property manager to have that work undertaken. The second stage was a little bit more about lab and the technology. We had to find out more about how the technology worked. We wanted to find out how far the reader can read a label, how many layers of construction it can see through before it stops seeing, so to speak. So can it look through plasterboard to find out to tell you what size timbers are involved, because that might be important later on for compliance testing, and knowing that a panel that's come out to site prefabricated actually complies with timber design requirements. We also needed to find out about the software that was used, and we explored looking at developing our own apps for a smartphone. We also looked at what was available in a proprietary sense, and we eventually did go with a proprietary option for our more detailed testing. We then went out into a more detailed level of development, I guess you'd say, where we were designing for field application. So we then went into designing databases to work out what locations there'd be readings taken. We looked at different types of radio frequencies. We needed to look at the process from this point of view of everybody involved. There might be a shipping manifest from, for example, cross-laminated timber coming from Europe, and you need to pick up the RFID readings as soon as it arrives on the docks or when it goes into logistics storage, and then you need to carry that lineage through to the factory and so on. So we needed to map all that kind of stuff, and then eventually we went to a field trial scenario, which we did with Strong Build. We implemented a system with them. We trained up their staff on how to use the technology. We made the database active for them to use, a cloud database. And then we just let them play with it and use it for a while to see how it went and its practical advantage for them. And then essentially the project gradually drew to a conclusion as we finished up that field testing, and we could look back on things and decide how and where it's most useful for the construction industry.
With the different users involved in this research, what kind of benefits did they experience?
Okay, it's a good question. It depends quite a bit on the type of business you're running. So, for example, we found that it was quite well suited to companies like Strong Build and others who are what you might call vertically integrated. They buy in raw material, they process it and fabricate it, they design or are involved in the design of the building, and then they construct it on the site. And other larger companies might even go on to own that building and operate it. Because it monitors an object, as I said, in this case a panel, through a process, it picks it up from when it comes into the country, it picks it up when it comes into the storage yard of someone like Strong Build. It allows them to time and date stamp that. They know how much inventory they've got, so they know whether they can feed a project or a building site because they've got enough feedstock. It helps them, once it gets into the factory, to realise if they're using their machinery and equipment effectively, because it can tell you once it's left the storage yard until it's finished being processed how long it took. So they know how many square metres an hour that factory production line is producing. There's also a need to order a delivery in a stack that suits what's going to happen on the building site. The building site needs to be able to tell the person in charge of inventory, here's the panel we need first. We need ground floor panel 10 first, then we need 11, 12, 13, 14, 15. This is the order that the crane's going to work in. It gives you time to deploy your staff accordingly on site, get the crane ready, work out that the staging area can accept those panels. And so the more they have a need for a continuous information flow from one stage to the next, the more they're going to be interested in this RFID technology.
So taking a step back then, what actually prompted the research? Was it just the kind of growth of prefabrication in general?
I think there's a desire in Australia and worldwide to make timber a more expansive material that's not just for 1 and 2 story buildings. It's pretty clear now you can build quite tall buildings. And so with that, for timber to provide a point of difference relative to concrete and steel construction is largely around its ability to be a lightweight material that's easily prefabricated. Prefabrication means you've got very big parts, you've got a lot of them, and they have to go together like a very simply put together jigsaw puzzle. And that's where RFID technology helps, because it glues those together in information terms. It makes it easier to put them together because you know how they go together.
What feedback have you had from industry, including companies like Strong Build, for example?
It's something that they know they need, because as they've grown as a company involved in this type of prefabrication, there's quite a learning curve you go through, and you recognise the need to refine the process to make it more cost effective. So this is a necessary refinement for them that makes things more practical and easy to use. They see, and others in the timber industry, quite large companies who are also implementing it, people like Lend-Lease and others, recognise that there's even future value adding, because you need to have compliance inspectors coming onto the building site, and for them to be able to easily read and download documentation about panels provides a quality assurance system that suits the compliance and certification systems. So it's an area that will become increasingly populated as this type of technology and prefabricated timber construction increases.
Perry suggested calling StrongBuild director and partner Tim Strong for a chat. StrongBuild is a pioneering company in the prefabricated construction space, and Tim worked closely with Perry by implementing and testing this RFID technology within the company's own operations.
How did you come to be involved with this project?
We met Perry on a tour through Austria where we spent a number of weeks with each other. Through that period, we got to talk about different technologies and other ways that we could better implement, quality processes or tracking systems around where did the species of timbers come from, what is the moisture content, how does it get to Australia, when it gets here, how can then we track, from, end-to-end process where the material has been and gone. When we got back to Australia, so then Perry then asked us if we could then do a study with him and do the process from end to end and track it.
Could you tell me a bit more about what your involvement's been to this point?
Look, we had obviously had all the equipment put into our facility, and we tracked with our team the timber and the material coming into the factory. The materials are then being processed. We then re-tagged using the RFIDs from the factory into the manufactured product, and then when it went to the project, then we were tracking, or I'll say more Perry's team were then tracking the lift times, the sequence times, and the actual manufactured parts going into the building. And working with our store manager in our factory to make sure that he was cataloguing all the parts, and as they're moving through our software, as well as physically coming in and out of the factory.
Okay, so from your perspective then, what have been your main findings in going through that process?
I think it's opened their eyes into how using the technology can provide